So the topic today is going to be auto-scaling in the cloud. And my name is Scott Reed, and let me just give you my blog. I run a company called Brain Hertz Consulting, and the Hertz is the cycles per second abbreviation. And I specialize in architectures and things like that, architectural reviews. So, and I'm also writing a cloud course for Developmentor. And this is a cloud course that is going to cover not just Azure or Amazon or Google, but sort of look at all of them and try and figure out the differences and where one would be more appropriate than the other, etc. So one aspect of that is obviously auto-scaling. And we'll go over the definition of auto-scaling and what aspects auto-scale and how that will work for your business. To explain that, first thing I want to show you is this graph, which is, you've probably all seen this. This is the planned load. So, I've got some users, and I'm going to start a marketing campaign, and those are going to ramp up the number of users. And then I'm going to stop the marketing campaign, and the users are going to plateau off, and then I'm going to start another, and it's going to increase again. That's your planned load. And so in order to be able to support that planned load, you're going to need to scale your hardware at certain times. And that's what that graph looks like, right? So that's how much compute resources you can support over time. But then the actual users start hitting your site, and that curve is never exactly as you had planned. And so maybe that looks like this. There's two aspects that the cloud can help with here. The areas in light blue there, those are areas where you have over-provisioned. You are paying for a lot of hardware that you don't actually need right now. And that's a problem, but it's not a huge problem. The worst problem is when you have users, you have more users than your hardware can actually support. And so if people are trying to access your web page, they're getting turned away, things like that. They're getting bad responses. The existing services are slow for everyone else. People are having a negative experience with your maybe your site, and they are probably not going to be coming back. And that's why people generally prefer to be over-provisioned rather than under-provisioned. So the important aspect of this as it relates to the cloud is the cloud can actually dynamically follow that line exactly. So as it detects that more and more users are hitting the system and that load is increasing, it can just add servers on the fly at that time. And as it's dipping here in the light blue area, it can go ahead and remove some servers so that you're not paying for them. And that's the idea of auto-scaling, or sometimes called dynamic scaling, or elasticity. That's my dog, in case you could hear. This slide you've probably seen before. This particular one is courtesy of Brian Loskin at Microsoft. And it talks about the service models, or X as a service type things. So on the left there, you've got your traditional IT, where you are basically managing everything, and that's where you would have a problem when you have to increase the hardware to support the additional servers. In the second column there, we have infrastructure as a service, and that's where the infrastructure provider, the cloud provider, is basically giving you all of the hardware and a base operating system. And you manage, patching the operating system or tweaks that you want to make to the operating system, as well as putting on any middleware and runtime and installing your applications and so forth. So it's really like, kind of like they own the hardware, you own the software, but not quite. And then you've got a platform as a service, and there the only thing that you're giving to the provider is your application and your data. They take care of everything else. So in terms of who is what, a good example of an infrastructure as a service provider is Amazon. They're probably the most famous. And some good examples of platform as a service offerings are Google App Engine and Microsoft Azure. We'll talk about one other one, I think, later on. And then to the far right there, you've got software as a service, where everything is handled by the vendor, and you just need a browser to connect to it. And you're familiar with things like that. Google itself, the Google search engine is software as a service. You just point your browser to a particular place, you type in a search, and they handle everything for getting your search results back. Another common software as a service vendor is Salesforce. Those are good examples. Okay. So one of the first slides I wrote for my cloud course was this idea of cloud philosophies. And we're going to be talking about 4 major providers today. These are like public cloud providers. We're not going to be dealing with any of the so-called private cloud providers. So like HP and Oracle and IBM to some degree. We're not going to really cover those. We're talking about the major public providers. So, and you've got sort of 2 sides of this coin here. On one side, you get the maximum amount of control and you get access to everything. And on the other side, everything is simplified and automate, and you really get access to nothing, right? So on the left here for access to or control over, you've got Google App Engine. And they basically give you access to or control over nothing. You hand them your application and it's hands off. We'll do the work for you. You don't need to know anything about what's going on underneath the covers. We'll take care of it. And on the right there, you've got Amazon, where you have to go in and say, oh, I want a load balancer. I want the load balancers to talk to these instances. I want to configure IP addresses for these instances. When the limit reaches a certain amount, I want you to go ahead and add another instance and so forth. And then sitting in the middle, you've got some, simplification and automation, but you still have some access to the actual instances and some control over what's going on. And those 2 are Rackspace and Windows Azure, as it's properly called. Okay, and then at the bottom, you've got the reverse, where Amazon doesn't really simplify or automate anything. Actually, that was true up until, I would say, the beginning of this year. And then they started releasing more and more products that would basically simplify and automate things. And we'll talk about some of those at the end. But up until this year, you had to do everything yourself. There was nothing that was really automated for you. And then Rackspace and Windows Azure help you out a little bit there, and Google App Engine basically controls everything. Okay, so the first one of these we're going to look at today is Amazon. And there's 3 ways to interact with Amazon. You can use the software as a service GUI application that they provide called the Management Console. You can utilize the command line tools, or you can access the APIs programmatically either through REST or SOAP. So let me just quickly first look at the Management Console. And that's this. And I've already logged in, but you can see I have an EC2 dashboard here. Oh, looks like I've been signed out. Let's see that one. Okay. And I don't have any instances currently running, but I could launch one if I want. And here you see images. These are the things that your instances are created from. So I have 2 instances here. Looks like 1 Windows and 1 Linux instance. I've got some elastic block store, like the extra drives that you can tack on to your instances, or sometimes they are what actually are the drives for your instances. and you can take snapshots there. And then we've got these networking and security stuff, which we'll look at a little bit later. So elastic IPs, this is how you create a group of IP addresses that all of your instances will live within. And then also a load balancer will basically take incoming traffic and route it to the appropriate instance automatically. All right, so that's the management console, and you can do a lot of things through that. But in order to do anything more complicated, you're going to need to go to the command line. Now, to set up the command line, you can search for a, let's see, what is it? It's called the developer guide or something like AWS developer guide. Yeah, that might be it. And there's a thing called Getting Started with the Command Line Tools, and there's a little document on setting up the tools. Right, and it talks about where to download them and all of the environment variables and so on that you have to set up, and you have to download your private keys and point to your particular certificates that you want to use with the tools and so forth. Because obviously all of these APIs are going over HTTPS, and they're secure, so that other people can't access your data and your instances. Okay, but I've already done that, the setting up of the tools. So let me show you this. Let's see. AWS tools. Okay. And mine looks a little bit more complicated than maybe the average one, but you're always going to have some little batch file or script file which basically sets up, where your Java is, because all of these tools are written using Java underneath the covers, the various keys and credentials, the URLs that you're using. So this is especially important when you're using different regions. Amazon is hosted within 1, 2, 3, 4, 5, I think, regions now. You've got US West, US East, Europe, and 2 Asia Pacific regions. And so you have to tell it exactly where you're pointing to. Then we've got the environment variables, which point to the particular APIs that you'll be using. So today I'll be using these particular EC2 APIs, these load balancing, CloudWatch, and auto-scaling APIs. And so that's what a common tools looks like, a tools setup. And then, of course, the REST API and the SOAP API, I don't have this in a particular slide. I do probably have notes with this somewhere. Let's see. No. No, sorry, thought I did. No. Okay, sorry about that. But there is a document that you can find that basically talks about which APIs are available through REST and which APIs are available through SOAP. And most of them are available through both. But there are differences. It depends on the particular API that you're accessing. So load balancing, for example, commonly used with REST, and EC2 you can access through SOAP and REST. Any questions? No. Okay. Good. So the next thing, when we're trying to auto-scale, the way we're going to, this is in general across all cloud platforms. What we want to do is we want to set up a load balancer which will balance across all of the instances that I have running. So if that's 1 or if that's 20, it doesn't matter. However many are there, it's going to route traffic to those in a round robin or fair sharing fashion. And then the monitoring component, each instance is going to be responsible for collecting its own data. So if we want to grab like CPU utilization, obviously that lives on each particular instance, and there needs to be some sort of component there that's going to collect that data. Then there needs to be something that basically takes all of that data and aggregates it across all of the instances. Like if one particular instance is running hot and the rest are not, then you don't necessarily want to scale out, right? You want to take a nice average, and if the average is running hot, then you might want to go ahead and add up another one. And then you also want something that starts the instances based on those rules. Okay. So those are the four components you need: a load balancer, a monitoring component, something that aggregates the monitoring, and something that starts the instances. And for Amazon, those things look like this. You've got the load balancer, called the elastic load balancer in Amazon's case, and that's going to route traffic to particular instances. And then each of those instances, as I mentioned, is going to be producing monitoring data, and that's all going to feed into an Amazon component called CloudWatch. And then CloudWatch is going to aggregate that data and pass it to AutoScale. And when AutoScale sees that, or when an alert fires, basically from CloudWatch, AutoScale will, create another instance or destroy the instance as necessary. So that's how it all works with Amazon. And so the individual steps that we're going to go through here are, first, we're going to create an elastic load balancer. Then we're going to create a launch configuration, which is basically an image ID. As I mentioned, that's basically a snapshot of a VM that you're going to launch instances from. And then the instance type. So do I want to bring up a large instance, or do I want to bring up a bunch of small instances? Those sorts of things are the instance type. And I'm just going to be using small instances today. And then we're going to create an auto-scaling group. And in the auto-scaling group, you basically say, this is my minimum size configuration. This is my maximum size configuration. Here's the elastic load balancer that I want to use. And here's that launch configuration that I set up previously. And then you create auto-scaling policies. And these policies are basically just actions that increase or decrease the instances by either a fixed amount or by a percentage. So I can have an action to basically increase by 1 or an action to decrease by 50%, for example. Then we're going to create a CloudWatch alarm that's going to trigger the policy action. So CloudWatch alarm basically says you need a metric, an operator, and amount in a unit. So, for example, CPU utilization greater than 80%, or 80 would be the amount and the percent would be the unit. For 60 seconds on average across my whole auto-scaling group, so that's the aggregate is the average in the period of 60 seconds, then I want to execute some policy, like increase the instance count by 1, for example. So that's how it's all going to work. There's a old password I have, which I'm not sure why that's in the middle of my screen. Okay. So there we have use the management console to create a load balancer. Then we're going to show how the load balancer detects instance state. And then I'm going to switch back over and I'm going to use command line tools to create an auto-scaling group, and we're going to watch as instances are started and stopped. Any questions before I start doing the demo? No? Okay. Well then, let's head over to the console first. And I'm going to look at load balancers. And I do have a load balancer set up. And I could create another one if I wanted to. But this one's a load balancer on port 80, and it runs across the US West zone. So 1A, 1B, and 1C. And that's a good idea. If you're creating a load balancer and you're creating instances, you might want to bring up instances in different availability zones so that you are more robust in the face of some sort of disaster. Okay, but I have this load balancer set up, Now, let me go ahead and launch an instance just manually first. Let's see, I've got one already here. Yeah. Select. So I'm just launching a Linux instance right now. I feel like I pressed the select button, but I'm not sure if it's actually working. Okay, let me try one more time. There we go. Okay, so number of instances 1, availability zone no preference, it'll just put it wherever it wants, and we're going to create a small instance here. Okay. So notice that when we try and launch this instance, the monitoring thing here, which says enable CloudWatch detailed monitoring for this instance, additional charges will apply. What you get for free in Amazon is basically a metric or a look every 5 minutes, I believe. And if you want like every minute or something like that, you'll have to turn this on. User data, so this is if you want to pass additional parameters to your instance when it starts up. And then, good, let's just go ahead and go. And I don't need any of that. So I already have a key pair that I'm going to use, which is Demo Linux. Security groups, I'll just say Scott Work, that's my machine here, and I want to be able to access it from here, so that's good. Is this great? Yes. Launch. Okay, images are now launching. And we can see that it's pending, and because it's a Linux instance, it should come up pretty quickly here. And when it does, I'm going to go ahead and associate it to a load balancer. And then I'm going to log into that instance. And I'm going to stop the HTTP daemon. And then I'm going to verify that the Elastic Load Balancer detected that it's no longer running. Okay. That'll be the first part of the demo, and then we'll switch over to the auto-scaling portion. Okay, so we got this thing up and running. It has a public IP somewhere. Here it is. I'm going to copy that, and I'm going to go over into PuTTY. It should just be in my command line. I'm going to paste in the IP address there, or the public DNS. And there's one other thing you have to do, and that's specify the location of your private key. I think I used Demo Linux. And here we're telnetting into this instance, or secure shelling into it, actually. Oh, that's not good. Let me make sure I got the whole thing. Paste. 204, 236. Yes, looks right. Why did it not work? I did use Demo Linux. Let me just make sure that I've got my security group set up correctly. 76, 238, 237, 177. IP. Oh, oops. This is the, my bad. This is the one that basically just doesn't allow the secure shell. I should have just created a separate group. Let me just create another one. Okay, so we'll say Scott Work Linux, and that's fine. Okay, And then I want to go ahead and create SSH. And I want to allow only me. So let's just go over here and go to what is my IP.org, I think it is. Man, it's running slow today. Grab that value. Previous one timed out, that's okay. Paste. Oops. Okay. 24 or 32, doesn't matter. Okay, save. That's weird. Oh, yeah. Okay, so there you have it. It's set up so that we allow port 22, which is the secure shell port. And now I want to basically associate that to the instance. So let's see how I do that. Is there a change? No, okay, bummer. All right, so let me go ahead and stop this. And while that's stopping, we'll go ahead and launch another one, this time quicker. That's weird. I don't see the security group that I just created. What's going on? Did I not create it in the right zone? So these are the sorts of things that trip you up in Amazon. No, that looks right. I wonder if I can change the security group now. Instance type, no. Okay, so let me go ahead and launch another instance. See if I can get my security group going here. If not, we might just switch and move over to the next part of the demo. What I was going to show you is basically just the fact that the load balancer will automatically detect when a device or when an instance is not available. There it is. Okay. All right. So this time we've got a different security group, which will hopefully allow me in. Security group is basically, as you might have guessed, just like a firewall. And you've got to configure that correctly. Okay, we're pending. Takes a couple seconds here. Any questions while this is happening? Oh, there we go, running. Okay, so let's try Putty one more time. Let's grab the IP address of this running instance. Okay, I may have said that. Okay, and paste, looks good. And then we go over here to auth, and we browse, and we choose Demo Linux, and we open. Ah, so much better. Okay. Yeah. Need the key. All right, here we go. We're here inside of the running instance. Actually, I don't know where I am right now, but okay, great. And so if I want to figure out the state of my HTTP daemon, I think I say service HTTPD. I'm not a Linux expert, by the way. Service HTTPD, hit status. Okay, so it's stopped right now. So let's go over to, well, let's start it first. Oops. So let's go service HTTPD start. Okay, it says it's okay. Now if we go over to Amazon and we paste, we should get this same hello world. And we're not taking too long to respond. That's, oh man, I made another mistake. I meant to add 80 as well as 22. Okay, so this demo isn't going so well, but what I want to show you is basically what the Elastic Load Balancer thinks of this instance. So first we need to associate the Elastic Load Balancer with the instance. So go over here to Load Balancers, and I want to instances maybe. And no records were found. Manually add instances to load balancer. I want to select that instance. Okay. So that particular instance is being load balanced. So there's only one. And you can see here that the status is out of service. And that's the same reason that this thing didn't detect properly. And that's because I forgot to allow 480 into that instance. As I said, everything with Amazon is very manual, and every little mistake that you make, means that you just basically have to configure everything yourself. All right. Now, the second part of the demo, what I want to do is walk you through actually creating all of this stuff programmatically. Now, I've already created a load balancer, so I'm not going to do that. But just to show you how to do that from the command line, let me go ahead and first run this AWS tools that I talked about before. And that sets up all my environment variables and so forth. And now if I show you how to create the Elastic Load Balancer, okay, you're going to use ELB create load balancer. I called mine Brainhertz load bal. You saw that. And then I've given it the region and the listener and the availability zones. Okay. Now the second thing we're going to do is we're going to create a launch configuration. So if I look at that, and basically you have to specify the image ID, which is that same image ID that I was using before, and the instance type of small. So let's go ahead and do that. It's basically saying launch configuration by this name already exists, and that's true. I've already set it up. So now we're going to create an auto-scaling group. This should already exist as well. So just to show you how to create it. And by the way, there is a great reference online. In fact, they're sitting right next to me here at my desk. There are these things called the quick reference cards. And if you go into that same place where I showed you the developer tools, where those things are found, you can print out a set of cards that basically gives you a quick helper around the APIs, the command line tools. And because this stuff is, especially the AutoScale and load balancing and so forth, this is stuff that you're going to set up once and then totally forget about. It makes sense to use the command line tools just so you can, you basically manually run these command line tools and you don't ever have to worry about it again. Okay, so let's run the AS3, create the auto-scaling group. And it should say that configuration already exists. Oh, it actually says it created, so I must have deleted this one. Okay, and we're using that same load balancer, and we're saying that the minimum size is 1 and the maximum size is 5. And you can also say, what's it, AS describe. Oh, and here's another trick. If you can't remember exactly what it is that you're trying to do, but you remember it's like describe something, you can just do a dir and /s, and you'll see all of the describes that there are. So I want to describe the actions that have taken place. That's what I want. Describe the scaling activities. Now that is weird. Oh, right. I forgot to say region US West 1. Is that right? So all of the command line utilities, you basically need to specify the region, or you have to specify the region inside of the environment variables. And this is extremely weird. I've never gotten this error message before. We currently do not have sufficient small capacity for your request. That is very interesting. So I'm guessing Amazon is having some difficulties at the moment, which is very strange because I've never had a problem with them. Okay, moving on. Botching them left and right here. We've got the policy actions. So if I show you what that looks like. Here I've set up two, one to go up and one to go down. And again, you specify the region, the group, the adjustment. And the adjustment for the -1 is really tricky. The command line is just not at all intuitive. So be careful and be wary of that. And both things we want to change in capacity. And you can actually list all of the different types of policies that there are. And then there's a cooldown period, which is an optional thing, which basically says if a action is currently taking place, don't do anything else for, in my case, 300 seconds. Right? So if I'm currently scaling up or scaling down, don't scale up again for 300 seconds. All right, so if I run these, I don't know what's going to happen here because of the. Okay, and it gave me, when it ran, this incredibly long, impossible to type little ID here. And this incredibly long, impossible to type ID is what I need to pass into the next things that I'm going to run, which are create alarm to trigger policy action. So if I look at that one. Okay, so you basically tell it to set up an alarm, and I named this one CPU high, and you give it a description, CPU greater than 75%. And you give it metric name, CPU utilization, average of 60 seconds. The threshold is 75, and the unit is somewhere here. There it is. Unit is %. So basically, if CPU utilization, the average, is above 75% for 60 seconds, that's where this alarm will take place. This alarm will kick off. And the dimension that I'm looking across is everything inside of my Brain Hurts AutoScale group. And then in the alarm action, this is where I pass that really incredibly long and difficult to get right policy. So you can see it starts out the same, looks like. And then scaling policy, and then here's where it starts differing, right? The GUID is different between here and here. But anyway, so you'll set up both of those alarms, and then what you'll see, at that point you're done. You've basically just done AutoScale in Amazon. As the CPU utilization gets above 75% across the average of your AutoScaling group, it will automatically spin up another instance for you. Okay, question. Okay, how do I connect with a Windows instance? So Windows instance is the same way, except for you connect to it via RDP. Can we add multiple instances at a time? Yes, absolutely. So this adjustment that I just specified there, that can be, here I just said 1 and changing capacity, but that can also be a percentage. So I can say, I want you to go up by 50% every time or something like that, if you want. And I forget what the final part of the question was. Can I import my own virtual machine? The short answer is no. In Azure, they now allow you to utilize Hyper-V and set that thing up, but really the answer is no. So what you can do is you can start with an instance that has pretty much everything you want on it, and just customize it from there. You know, they do have tons of different instances or images, sorry, that have both Windows Server 2003 and Windows Server 2008. Okay, hopefully that answered all of your questions. Okay. All right, so we've got Amazon. Well, most of these demos were kind of botched because I didn't set up the security policy very well. But the load balancer will detect the fact that it's not running automatically, and then independent of that, you can specify an alarm when a number of instances are not responding or something like that. Instances should get stopped and started basically automatically. Okay, so the second cloud provider that I want to talk briefly about is Rackspace. And the reason why I want to talk about it is because they've been gaining some market share against Amazon. And one of the numbers that I looked at recently had them neck and neck. If you go to, good lordy, like Jack of all clouds or something like that called. January 2011, that's the one. Yeah. So this particular, the person here has them at roughly even in terms of, these are all infrastructure as a service, so he's not counting, you know, Google App Engine or Microsoft Azure or any of that other stuff, just the infrastructure as a service providers. And you can see that they're pretty even. Okay. So that's why I want to mention them. And they basically have two policies or two different types of providers. They have a cloud server provider, which is an infrastructure as a service provider. And they do have a REST API, but there are difficulties when dealing with IP addresses. They don't really have a great story for that right now. There is an Elastic Rack project on Google Code, which I have downloaded but haven't actually played with yet, which is supposed to fix that. issue. I don't know if it will or not, but so that's the cloud server. So I'm not going to cover that because it's not really possible to do the same thing that you can with the Amazon. However, the other project or the type of platform that they have is a cloud sites. And this is platform as a service. And for $150 a month, they scale your application as needed. And you get certain quotas, but you know, if you go over those quotas, it's just a pay-as-you-go type model, you know, just like Amazon is. Okay, so cloud sites may be a good option for you if you want an infrastructure, or I'm sorry, if you want something more than a cloud, than an infrastructure as a service provider. You basically just want to give them your application and have it scale automatically without having to worry about setting up all that stuff that we did for Amazon. Okay, so moving on, the rest of the things we're going to talk about are platform as a service. I just mentioned it with the Rackspace cloud sites, but Microsoft Azure and Google App Engine are all platform as a services as well. And the idea around the platform as a service is that, you know, you're basically going to have a platform on which your application stands. You give the application to the platform, and it does the right thing. You know, it holds it up. No matter how many users are thrown at it, right? That's what it does. It holds it up. That's the idea. Microsoft Azure was designed as a platform as a service, but it was architected as an infrastructure as a service. So, you know, in an infrastructure as a service, you're basically doing everything yourself. Now, because it was designed as a platform as a service, the load balancer is taken care of automatically, but you basically have to rely on programmatic access or third parties to do everything else. And so when you're doing, you know, Azure Auto-Scale, you are kind of playing at the infrastructure level. You know, this is the underneath the bleachers, basically. You are dealing with all this infrastructure. Okay, and the way that Azure works is you have these roles, either web roles or worker roles, and there's on the instance itself, there's a separate process called the diagnostic monitor. And the diagnostic monitor is reading from and writing to the local directory storage. Right, your role calls start on the diagnostic monitor, and then it is basically reading and writing all of the performance counters or any other metrics that you want to capture. Okay, so then diagnostics, the diagnostic monitor can be set up to periodically transfer event logs or performance counters or whatever into Windows Azure storage. Certain types of metrics go into blob storage, and certain types of metrics go into table storage. Performance counters are one of the examples that go into table storage. And then from another cloud instance or from your local desktop, you basically can look at the table storage and decide whether or not your application needs to scale up or down. And then there's a separate set of APIs called the service management APIs that allow you to do that, to do the scaling. Okay, so in Azure, we're going to look at first collecting the metrics. And the problem here is that Azure gives you a little bit more flexibility than Amazon. So in Amazon, if I go back a couple of slides in the notes, I think I had, yeah. These are the sort of metrics that you can have in Amazon at the bottom there. You've got CPU utilization, disk read bytes, disk read ops, disk write bytes, disk write ops, you know, so on and so forth. So basically you've got CPU, some disk stuff, some network stuff, and healthy and unhealthy, right, and latency. So those are the sorts of things that you can do, you can get metrics around. Now, if you have custom metrics that you need to track yourself, that's really impossible to do through Amazon. And Azure lets you do it. So it's a little bit more flexible than what Amazon provides. However, you have to do more work in order to support it. Okay, so let's flip over to Visual Studio and take a quick look at some of this stuff. Okay, so it looks like my application finished deploying, which is good. So the first thing I want to show you is the web role, and in the web role there's some code, initialization code, some startup code that you need to do in order to set these things up. And the first one is if you want to. So in my particular case, I was trying to show off the power of the Windows Azure, and I was basically creating a custom performance counter. So I have the normal percent processor time across all of the processors on this box, and then I also have the fake CPU that I want to look at. And when I say across all the processors in this box, of course I'm talking about in the VM itself. So you want to obviously see other virtual machines that may be running on the same physical box as you. Okay, so anyway, I've created the custom performance counter, which the code isn't really as important, but it's just standard .NET stuff to set up the counter creation data, and it's called performance counter category create. And then the next thing is I grab the initial configuration of the diagnostic monitor. So there's the default set of logs and so forth that are set up, and I'm being called by development for, which I'm going to ignore right now. Mary, if you can't hear me or something, please let me know through chat. I'm going to assume that was not you calling me. Okay, so the diagnostic monitor, get initial configuration, gets the stuff that's logged by default. Then we grab or we add in our performance counter data sources into this set of stuff that's grabbed by default. So I'm adding 2 more things to be grabbed. And I'm also scheduling a transfer, and as you remember, that's transferring that set of data over into Azure storage. So if I go back to this slide, right, transferring into the arrow that's number 5 there, that's transferring over into storage. And I'm doing that every minute. And then I just go ahead and do the diagnostic monitor start, and all of that stuff will be taken care of for me. So I have to set up some stuff inside the role itself, which we didn't have to do in Amazon, but it was more flexible in Azure. Okay, the second piece that you need to do is something to actually get the performance counter data, and this can either be done on an instance locally or on a remote instance. So it can either be done in the cloud or out of the cloud. And we've got the standard way of interacting with that is using the storage client, and you have these entities, and this is what a performance counter entity looks like. And then of course you've got a data context, and we're querying out of the Windows Azure Diagnostics Performance Counters table. And so we grab that, and we can get all of the counters. We can sort them using whatever link queries we want. So once we've retrieved those performance counters, we now have to make sense of them and basically decide whether or not to scale up or not. And when you get over to deciding whether or not to scale up, that's where the service management APIs come into it. And unlike the rest of Azure, which has a .NET SDK associated with it, the service management APIs are still just straight REST APIs. So you actually have to do a little bit more work in .NET to make these things work. In particular, because we're going to be using SSL, we're going to be dealing with certificates. They're going to have to write a little certificate code and code to create web requests that add in a certain number of headers. And so here I'm adding the XMS version and request method and then the certificate. And then the rest is just straight REST, and XML. So, for example, here I grab the deployment configuration based off of this particular subscription ID and service name and slot. So this, in Azure, again, there are two slots. There's ones for staging and ones for production. And here I'm grabbing the production slot from the Scott's Demo service at this particular subscription ID. And if I just go ahead and run it, uh-oh, I ran the wrong thing. My bad. Let's do, actually, let's just do this. Let's stop it. Why is it not running? Oh, still not running yet. Okay, doesn't matter. While that's running, let's do a debug start new instance. What it ran actually is the cloud project, which if you run that locally, it's going to run inside of the emulator on your local machine. All of the platform as a service offerings actually work like that. So it doesn't matter if you're talking about Google App Engine or Beanstalk or whatever. You set up some code locally on your own box that basically simulates the cloud environment. Okay, but I stopped that deployment and I ran this. And I said get deployment configuration, and this is the document that we get out. Looks like this. So we've got the service configuration. This is the same document that I uploaded as part of the Azure deployment. So it's this document basically. And I parse that, and I grab out the service configuration and the roles and the instances. I get the count. The count is currently 1. I parse that, I increment it, I set it back, and then I update the deployment configuration. And this is what the body of that REST request needs to look like, just a little bit of XML there. And I've base64 encoded that configuration. And I send it to that address. And I send that up into the cloud. And let me just look at the response. And it was accepted. So what we should have done there is automatically spin up another instance. And if we go back to our console, we should see another instance being created here. Yep, there it goes, just started. So now we have 2 instances being hosted inside of Azure. And so that's basically how it works with Azure. Everything's sort of programmatic, gives you a little bit more flexibility at the expense of you having to do a little bit more work. We're running about 5 minutes over. Anybody have any questions? Oh, good lordy. This is a good question. Okay. Is it possible that an overworked server can automatically trigger any instance to scale up and down for the entire deployment? We have 40 Windows servers and 20 Linux servers. Can we do load balance for all of the servers? All the servers are located in different time zones. Okay, so that's one thing. Well, first of all, are we talking about Azure or Amazon? I assume we're talking about Amazon because that's what your questions previously were on. And if you're talking about Amazon, then no, you cannot balance across the different time zones. You can balance across the different availability regions, but not across the different data centers altogether. In other words, you can't balance across, what is it, like West and U.S. West and U.S. East and Europe and Asia Pacific. You can't do that. Okay, but you can balance cross availability zones in the same time zone across all of your instances. So I believe you would have to set up two different load balancing scenarios there. One to balance your Windows servers and the other balance your Linux servers, because when you specify the rules, you basically specify a particular instance to start up when it gets, too high. So nowadays we're facing 95% plus CPU utilization in a peak production hour. Can we balance on CPU load? Yes, that is totally true. So, but I think what you're going to have to do it is, like, let's say you're running one in the US and one in Asia Pacific. When the US is awake, you want to spin up new instances in the US region. And when US is asleep and you're getting a lot of load, then you want to spin up instances in so you're going to have to basically set up two sets of rules in the Asia Pacific region. Does that make sense? Okay. Good question. Sorry I didn't see it right away. All right. But we do have, where did we leave it? Yeah. Okay. So we had started another instance there of the Windows VM. Great. Sorry. Okay. And so what do? We collected the metrics using the diagnostic monitor. We transferred the metrics to storage. We did that automatically. You can also do that on demand. We examined the metrics using the table storage mechanism to pull the metrics. We figured out when we wanted to scale, and we used the service management API in order to scale it. Okay, I just want to mention a couple of other platform as a service offerings that are out there and you may want to utilize. One is the Google App Engine, which actually, in terms of entry level, is the best for any cloud provider that I've seen. You basically have a pretty decent quota that you get for free, and they'll take care of, auto-scaling for you as you need it, as long as you don't go above the quota. If you go above the quota, you can pay as you go, for additional bandwidth or additional CPU utilization or whatever that whatever quota you've blown. But they basically give everything for free. And the reason why they're able to do that is because you are basically running on a machine with, thousands of other people. You don't have a dedicated instance. Unlike everybody else. So Google App Engine is a little bit different in that regard. That's why they give you such a nice free introductory package. So Rackspace Cloud Sites, I mentioned that before. You get $149 a month for a little bit of a larger quota, and then you pay additional after that. And then the other one, which is new, was just announced a couple of months ago, is Elastic Beanstalk by Amazon. And that is a pay-as-you-go model, period. So if it needs to spin up 10 instances for you right off the bat, then you're paying for all 10 instances. But it will, keep them online, and it does everything, all the auto-scale work that we just mentioned, it does that for you automatically. I should mention that if you're going to write a platform, each of these platforms are specific to the language you're writing on. That's part of the platform. And if you're writing for Google App Engine, you'll be writing in Java or Python. If you're writing in Amazon Elastic Beanstalk, you'll be writing in Java. And the Rackspace cloud sites offer you either Java or .NET. Okay, and I think that is it. So, are there any other questions? If not, then I will go ahead and get Mary to stop the recording. And thank you all for attending today. And this podcast and the demos associated with it will be online at the develop.com website for downloading later. Thanks again.